Welcome to Finding Areas by Integration. Areas and definite integrals. So an area is always positive. And we know from our work so far that the definite integral may be positive or negative, depending on whether it is above or below the x-axis. So for this, we're going to have a look at the steps when finding an area. So the first thing you should try and do is sketch the curve showing where the relevant intercepts are. The intercepts or the intersections, so it may be two curves that we're finding the intersections of, are usually the values for the integral. So that's something to keep in mind. We then calculate the definite integrals for each area, and then we calculate the total area by changing any negative area to a positive before adding. So slightly different to when we did the definite integrals. So we're going to have a look at three examples. One where the area is all above the x-axis, one where the area is all below the x-axis, and one where you have an area that is above and below, and how we just approach each of these different ones. So the first one, y equals 2x minus x squared. So we recognise that it's a parabola that's concave down because it's got the minus x squared. So we find where it cuts the x-axis, so that's when y equals 0. So you let 0 equal 2 and you take a common factor out the front, x outside of 2 minus x. So therefore x equals 0 or 2. And we can sketch the parabola and we're going to find the area enclosed with the x-axis. So here's our parabola. Concave down, remember it passed through 0 and 2 for x equals 0 and 2. Note that those two values become my integral. So it's the integral from 0 to 2 of the graph, which was 2x minus x squared. Now we're going to use an integral. Notice that this area is above the x-axis. So our answer is going to be positive in the end anyway. So going through your integral phase, raise your power, divide by your new power. Substituting in 2 and 0, you get 1 1/3 units squared. So we get an answer that's positive. So we don't need to do anything with that. We just know that 1 1/3 is that area underneath that curve, underneath the curve and the x-axis. Y equals x squared minus 9. So let's again, it's a parabola. It's concave up because it's a positive x squared. We know that the minus 9 shuffles it down 9 units. But let's find out where it cuts the x-axis. So when y equals 0, so 0 equals, that's a difference of two squares. So 0 equals x plus 3x minus 3, meaning that x equals minus 3 or 3. So once again, sketch the parabola and find the area that's enclosed with the x-axis. So here's our parabola. Passing the x-axis at minus 3 and 3. Once again, they become our integral values. So from minus 3 to 3 of x squared minus 9. Now straight away you should see this is all below the x-axis. So therefore we're going to get a negative integral when we integrate, but we're going to need to change it to a positive because we are talking about an area. So using our normal integral between minus 3 and 3, raise your power, divide by your new power, sub in 3 and minus 3, and you get minus 18, so you get minus 36, which is the integral. And then we know that because we're finding the area, and it has to be positive, that becomes 36 units squared. So the area between the graph x squared minus 9 and the x-axis is 36 units squared. All right, on to our final one. X cubed minus 4x. All right, so this is a cubic, but we're only focusing at the moment. We're not looking at where the stationary points are. We're only focusing on where it cuts the x-axis because we're finding the area with the x-axis. So factorise, take the x out the front. Then you get a difference of two squares inside, so you get x outside of x minus 2x plus 2, giving you x values of minus 2, 0, or 2. So we're then going to sketch the cubic and find the area enclosed with the x-axis. So we learned how to sketch cubics earlier in the year. So you plot your points, -2, 0 and 2. Pick a point above 2, the highest value of x, and determine whether it starts above or below the x-axis, and then sketch your curve. And so this is the curve that we get. So see, crossing at -2, 0 and 2, they give us our integral values. Notice that the first half between -2 and 0 is above the x-axis. So we're going to have to treat these doing two separate integrals. The first one is going to be from -2 to 0 of x cubed minus 4x. And the second one is going to be between 0 and 2, but we're going to have to get that answer as a negative and then change it to positive, because the answer is going to be negative because it's below the x-axis. So let's have a look. So let's start with the from -2 to 0 of x cubed minus 4x. So going our normal, raise your power, divide by your new power, between -2 and 0, substitute in 0, minus substituting in -2, and we get a positive answer. And we knew we'd get a positive, we get 4 for that, but we knew we'd get 4 because it's above the x-axis. Doing the same with the 0 to 2, because it's actually the same values just on the other side, 0 to 2, we will get -4 instead. So if you were to follow the same process. But we need to make that positive, so that becomes +4. Adding those two areas together, 4 plus 4, gives us 8 units squared. Thank you.